Okay, we're just going to look at exercise 4.4, question 5a, and we've got the distance of z plus 2 take I is equal to the distance of z take 3. Okay? Now, what we're saying here is z is the unknown. We're saying, for what values of z does this situation hold? Okay? Now, we could also rewrite z as being x plus yi. Okay? Plus 2 take I is the second part. Because this is the real part of this imaginary number, or this complex number z, and this is the imaginary component of it. So I could rewrite it like that if I wanted to. I'm going to do the same over here. X plus yi. Take away 3. Okay, now from here, this is asking us for the distance from the 0, really, of this part here. You could think of it as being the distance from this z value to negative 2 plus I if you wanted to, like we did in previous situations, but we're going to approach it from this angle here. Now, if I'm looking for this, I'm going to gather the real terms together. So it's going to be x plus 2 plus, I've got yi take away I, so that's the same as y take away 1 I is equal to, and I'll look at the real terms here, I'm going to have x take away 3 plus yi. Now, if I want to look at what's the distance to this point here, I can write that as, using Pythagoras, the square root of the real component squared plus the imaginary component squared. Okay? And that's going to be equal to, again, same idea, square root of the real component, x take 3 squared, plus the imaginary component squared. Okay, so if I go from there, I'm going to square both sides of this equation, just to get rid of that square root sign, make it easier to deal with. Okay, and then I'm going to expand out my brackets. Okay, so if I expand out this line, I'll end up with x squared plus 2x plus 4 plus y squared, take 2y plus 1, and it's equal to x squared, take away 6x plus 9 plus y squared. Now, all I'm going to do is gather like terms. I might even just bring everything over onto this side and make it equal to 0. So on the next line, if I take away x squared from both sides, I'll get rid of these x squareds. If I take away y squared from both sides, it'll get rid of these two y squareds. Then if I just noticed I made an error, because it's supposed to be 4x through here. Okay? So then if I add 6x to both sides, I'll end up with 10x here. Okay? And then if I add 4, I should take away the 2y first. Okay? 4 and 1 gives me 5. Okay, and then I'm taking away 9 here. And I think I've got everything that's equal to 0. Now let's just simplify this. So it'll end up being 10x, take away 2y, take away 4 is equal to 0. And then from here, if I try to make y the subject, I'll end up with negative 2y is equal to negative 10x plus 4. So I took away 10x from both sides, added 4 to both sides. Then I divided both sides by negative 2, and I'll end up with 5x take away 2. Okay, so if I divide that by negative 2, I get positive 5. Divide this by negative 2, I get negative 2. Okay, so that's my equation. Y is equal to 5x take 2. And so, remember what we talked about here? This is what we replaced it with. We said x was the real component and y was the imaginary component for this relationship. So if we were to graph it, we'd be looking at a situation where we have it crossing at negative 2. Okay, and we'd have a gradient of 5. Okay, so for every 1 we go across, we'd go up by 5. And I could even look for the other y-intercept. So if I added 2 to both sides, or made this 0, sorry, and then add 2 to both sides, divided by 5, then we'd end up with 0.4. So we're crossing somewhere about here. So that's 0.4. Okay. And this would be my real axis. This would be my imaginary axis. And you'd see that is these are the different z values that this statement at the top holds for. Okay? I hope that helps, guys.